and simplifying expressions with radicals, dealing with variables and numbers under our radicals. The next week we'll start solving equations involving all these radicals. So today we really just need to make sure we understand how these radicals are working before we get into all of the equations that we have to solve. So some of the problems are involving numbers. I'm fully aware that you can pick up a calculator and use that to help you, but is that going to help you next week when we're solving for x under a radical? No. So we're going to start with numbers to kind of understand, and then we'll get into the variables. So if I'm talking about a power function, if it's a power function, it's just x to some power. That's a b up there, where b is a constant. So x to the second, x to the third, x to the fourth. Those are power functions. But that power could be a fraction. So when it's like x to the, I'm going to say a over b power, that turns it into a radical. So if that exponent is a fraction, that is equivalent to a radical. And this means the index on the radical is b, the denominator, and the numerator is the exponent. That a can technically go inside or outside the radical, but it'll look like that. So if your power is a fraction, that is the equivalent of having a square root or a cube root or a fourth root, something like that, in our problem. The first thing that we need to recognize with these is the domains. If you have the domain of a square root, okay, can you do the square root of 0? What is the square root of 0? 0. What's the square root of 4? 2. What's the square root of 3? Or sorry, of 9? 3. We saw that back in chapter 2 when we were graphing the square root function. But what if I say the square root of negative 4? It's 2i. It's imaginary. When we are graphing it, did we graph the imaginaries? No. So when we are talking about a root function, if you have an even index, that's the number outside the radical. So that means like a square root, fourth root, sixth root, and so on. The radicand, the thing under the radical, has to be greater than or equal to 0. If it's less than 0, that's when we have imaginaries. So make sure you're jotting this down. We're going to have problems today where we're identifying domains, and this is what we're going to look back at. If it's an even index, the thing under the radical has to be greater than or equal to 0. Now, if it's an odd index, so that's saying a cube root, fifth root, seventh root, so on. Okay, think about when we graphed the cube root function. What did it look like? It was like that sideways chair. Okay, it went forever in both directions, right? The cube root of 8 is 2. The cube root of negative 8 is negative 2. So if it's an odd index, your domain is negative infinity to positive infinity. So if it's an odd index, you can put anything underneath. But if it's an even, then the thing underneath has to be positive. That was me yesterday, all morning. Okay, so let's practice. We'll first start simplifying some radicals with just numbers underneath. We'll do a few examples of that before we get into anything with variables. So if I ask you to simplify each radical, If I say the cube root of 27, what is that? Right. So if you're just evaluating the radical, it's saying basically what number to the third power equals 27. On the calculator, depending on which one you're using, if you have the graphing calculators, you would hit like the 3 for the cube root, then go into math. There actually is a cube root function, but if it's like a fourth root or anything, you have to go into number 5 to get the different index. If you are using these calculators, it's above the exponent button. So if there's numbers, you can evaluate them from there, or we might just know them. Bless you. B, if there's a negative on the outside, does that change anything? No, we just carry that negative onto our answer. What is the fourth root of 10,000? Grab a calculator if you don't have one, or if you don't know it. Should be 10. Do you guys figure out how to... Alright, everybody make sure you can put that in your calculator so I know that you know how to use them. Did everyone get it? Bryson, you grab a calculator so you can. Did you guys figure out how to put it in? You have to do second and the caret exponent button, which is to type in the for second. Caret.
No, I
You're welcome.
hate graphing. That's one of the reasons I hate what we can't do.
Alright. We get that? If you are typing it in the calculator, if you do the negative in front, you have to be really careful that it doesn't go up in your index. It's essentially -1 times the fourth root of 10,000. So just be cautious of that. Then a negative power would make it go to the denominator, so it would give you 1/10 instead. Alright, the cube root of -216. It's an odd root, so the negative isn't a problem. What does that give us? Make sure you can evaluate these. -6. What about the fourth root of -81? Type that one in your calculator. Is it? Why does it say an error? Yeah, the index is even. I told you if it was an even, what kind of number had to be under here? Not an even number, but a positive number. So your calculator doesn't do eyes. If there's a negative under there and it's an even index, it's just going to shoot you back a domain error and tell you that you can't evaluate that. So this one, it's not a real number. It would be imaginary. Now, what is the fourth root of 81?
3i.
So we would get fourth root of 81.
3i or do we just
So if this were, I was just looking, I don't think I gave you any like this on the Math Excel right now. So you don't have to worry about it on the homework, but I just wanted you to see what your calculator will tell you if you try to type in one that's incorrect. All right, a couple more. We can do fractions. The cube root of 125 over 512, you can put it in the calculator, but when we have variables, if we don't have the calculator, you basically just do the cube root of the top and the bottom. What's the cube root of 125? 5 over, what is the cube root of 512? So we get 5x. F, I have a negative on the outside. That's essentially just saying -1 times my answer. What is the fifth root of -243? And two negatives make a positive. So we have the opposite of -3 or +3. Are we okay evaluating those on our calculator? I'm going to put a couple up here. I want to see if we can do them without the calculator. If I said 16 to the 3/4 power. Okay, if I'm just looking at the 3/4 power, that's a little confusing. But I told you could write these with radicals. If you do that, the 4 goes outside. The denominator's outside. We have the 4 through the 16. The cube can either go inside or outside the radical. I'm going to put it outside. What is the 4 through to 16? What number times itself 4 times equals 16? Which is 2. So 2 to the 3rd power. 2 times 2 times 2 is 8. What is the cube root of negative 64? So what number times itself 3 times equals negative 64? Come on, guys. Negative 4. Okay, negative 4 to the 4th. What happens if you take a negative to the 4th power? Well, if you do a 4th root, it's a domain error, but we can take it to the 4th power.
It would turn out positive.
And 4 to the 4th, we get positive 256. All right. C. If we think about exponent rules, what would we do with those exponents?
Negative to a square root.
Well, you could go ahead and write it with radicals, but I would simplify it first. If you have power to a power, you multiply. So 3/4 times 2 is 3/2. So then if I write it as a radical, it's the square root of 25 to the 3rd. What's the square root of 25? So 5 to the 3rd, 5 times 5 times 5. 125. And D, negative 8 to the 5/3. What does that mean? How do I write it with the radical? Cube root of negative 8 to the 5th. What is the cube root of negative 8? Negative 2. And negative 2 to the 5th is negative 32. Okay, so when you have those powers as fractions, it is helpful to first write them with a radical. The denominator is the index, the number outside our radical. Any questions there? So now I'm going to throw variables up here. So we have to understand the radicals. We can't just plug them in our calculator. Okay, so we're not going to get a number answer here. We are just simplifying as much as we can. If I say the 5th root of x times the square root of x cubed. So how do we write the 5th root of x with an exponent?
X to the 1/5.
So this is just like an understood 1. It's always over the denominator. Okay, the cube root of, or the square root of x cubed, that would be x to what power?
3/2.
Okay. Exponent rules. If you are multiplying with those x's, what do you do to your exponents? Add them. So 1/5 plus 3/2. Over 10, actually 17 tenths power. And we could write it back in radical form, but let's just leave it like that. actually going to do, I'm gonna switch the order of my examples. This is gonna be B. This entire thing is under a cube root. So what power is a cube root? Okay, inside we have an x squared times the 7th root of x. How do we write that? So if I'm simplifying, these x's are multiplied, so what do you do to their exponents? Add them. So 2 plus 1/7 would give me. And then what do we do with the 15/7 and the 1/3? Multiply. They're a power to a power, so we multiply those, so we get x to the 5/7. I want you guys to do these two.
So you want us to leave it,
As a-
fraction or?
This one, the cube root of x to the 4th would be x to the 4/3 times the 4th root of x to the 5th would be x to the 5/4. So if those x's are written both times, you add their exponent, so we get x to the 31/12. That's the second one that we had more trouble with. How would I write a 6th root? And then inside we have x times the cube root of x squared, so that would be x to the 2/3. If there's no power written, what is it understood to be?
1.
So 1 plus 2/3 give me 5/3 to the 1/6. So then you multiply those exponents and you get 5/18. Questions on those? I'd like to switch gears and do a few domain problems if we could. So if I ask you to find the domain, what do I have to look at to decide my domain?
You have to look at, whether the root is positive or negative.
Not positive or negative, even or odd, because they have different rules. So when I look at the first one, if there's no index, a number outside the radical, then we know it's a square root. 2 is even. If you have an even root, then we know the thing under the radical is greater than or equal to 0, because it has to be positive. So if we solve that, 4x is greater than or equal to -12. So x is greater than or equal to -3. How would I write that as an interval? Parenthesis or the bracket on -3. It's a bracket because of the equal to. So if your index is even, it's just whatever's underneath greater than or equal to 0. And solve that. We've solved inequalities before, so that part shouldn't be new. Answer, I do expect interval notation. When I look at the second one, what's true about this one? It's odd. If your index is odd, what's our domain? Negative infinity to positive infinity. You don't have to work anything out. So because this is odd, my domain is just automatically everything. any questions about those? Let's do, I'm going to throw another one up here. What if I said, (36 minus x squared), the square root of 36 minus x squared. What would we do there? So is it negative infinity to positive infinity, or do we need to work something out? We have to work it out here. So when we look at this, because it's an even, the thing under the radical is greater than or equal to 0. Okay, if you add over your x squared, you get 36 is greater than or equal to x squared, or x squared is less than or equal to 36. That's a little bit tricky, because normally if it were an equal to, you would do a square root and a plus or minus, right? But with inequalities, it works a little bit different. So we have a couple options here. We've solved some inequalities, so we could think of it as like a sign line and work at it from there. You could also use a graph to help you. So if you square root, that would be a plus or minus. What is the square root of 36? 6. So if we treat it like a sign line, and we really just need to put the test points in here. So we found out the numbers that made it equal 0 because there were 2 of them. We had that square root, we don't just know it. So if we put in test points, so if I put in negative 7, I get 36 minus 49, which is negative. If I put in 0, 36 minus 0 is positive. If I put in 7, 36 minus 49 is negative. Which answers do we want?
From 96 to 6.
And the equal to tells me brackets, so it's just,
Is there any time where you won't get brackets because it's
nope, not on these.
So you look at what the inequality was first, the inequality sign was first,
Yes.
before you split it?
Yeah, before you started doing the solving. So I went back to when it was just the expression on one side, 0 on the other. Last type of problem I want to do today. I want to talk about just simplifying our radicals a little bit and going back to some of our transformation stuff at the beginning. We're not graphing it, I'm not asking you to draw a graph, but I want to see if you recognize how this would be related to the original square root graph. So if I were looking at this, I can't just say, oh, it's going to stretch by 4 and move left to right. I want to simplify this as much as we can. If you look at 4x plus 12, what do you notice about both of those? Both of these.
both even and they're both multiplied by 450.
Okay, so let's factor out the 4. So if I take the 4 out, and we could even bring the 4 out of the square root. What is the square root of 4? So this turns into 2 square root of x plus 3. So if we wanted to describe transformations, outside is a vertical stretch by 2, and what does the plus 3 do?
Left 3.
Left 3. So I'm asking about transformations, but I'm really more checking if, can you simplify radicals? Can we figure out what we can factor out and reduce here?
So if the 4x is in the radical, it does not need a vertical stretch.
Correct. For vertical, it has to be outside. Inside is horizontal, but it does have to be factored before you can base that or decide that.
Well, because some numbers won't be that easy.
Yeah. At this point, I'm only going to give you nice ones. All right. Final problem of the day, so another one of these. If I have the cube root of negative 8x plus 8, what could you take out of both of those?
8.
8. I like my x to be positive. Can we take out a negative 8? That would give me an x minus 1. What is the cube root of negative 8?
Negative 2.
So negative 2 comes out. So I just took that expression and I simplified it. So, what does a negative do? Mhm. What does the 2 do? And what does the minus 1 do?
Right.
There is a math Excel assignment open, so you guys have time right now.
So there we
Work
just put
that.
it into that form, I forget what they call it.
Yeah, you're just gonna get like that standard form where you just have an X underneath, nothing else.